Dear students, this is a shortcut method for any problem in derivatives. It's a very shortcut method. If you know this method, then you can solve many problems without going a long time, 5 to 7 minutes. You can do this problem within a minute. I have already given you one example. Suppose I am giving example 1. Y is equal to sin x to the power tan x. I have already taught you. Dy by dx. It is two things there. First you treat sin x to the power tan x. You treat tan x as constant. Treat as constant. First it take this is constant, then sin x to the power tan x. Then treat sin x as constant. It's constant. If tan x is constant, then you should, it is what? It is just your n. I am writing it here. It is just your n. So this becomes what? N into means tan x into sin x to the power tan x minus 1 into derivative of, you are doing derivative of the variables. Here the variable is sin x. So it is what? Cos x plus. So its work is now completed. Whose work? This work is completed. Now this work, you are treating sin x as constant. So you think it is your just a, means a to the power tan x. You know a to the power tan x. It is a to the power tan x means sin x to the power tan x into ln a means it is ln sin x into derivative of what? Derivative of the variable. Never take the derivative of constant. Derivative of variable is what? Tan x. Derivative of tan x, sec square x. I have already taught you this. Okay? Mind it. You will do this problem only for entrance oriented problems. Not it is for your CBSE or CHSC models question answers. Okay? Here you have to take two parts. This is first treating the exponent as a constant, next the base as constant. And after taking the derivative, you have to add it. Okay? I am doing this example for implicit function. And for this, first suppose before doing this example, I want to tell you the derivative of the partial derivatives. Okay, what is partial derivative? Suppose f is a function, it is x square y cube. Then someone is telling find d by dx of f. Then what you will do? X square, then d by dx of y cube plus y cube d by dx of x square. It becomes what? X square. And you know derivative of y cube is 3y square into dy by dx plus y cube into 2x. You know it already. Now I am telling you a partial differentiation of x of f with respect to x, and it is written as del f by del x, and it is also written as in the form fx, means you have in a log with x and treat y as constant. That means del by del x of what is f? F is x square y cube. You are in love with x, not in y. So y is your constant. So keeping outside y cube del by del x of what? X square. It becomes y cube into 2x, means 2x y cube. It is 2x y cube. Mark. If you differentiate partial differentiation of f with respect to y, It is del f by del y. It is what? Del y del y of y. Y means what? It is x square y. Sorry, f means what? X square y cube. In this case, what we will do? It is partial differentiation with respect to y. So x will go outside. X square del by del y of y cube. And del by del y of y cube, it is all, you know, it is 3y square. So x square into 3y square. It is 3x square y square. Okay. Now there is a new formula for this example too. What is dy by dx? Dy by dx is equal to minus fx by fy. And I am repeatedly telling you, this is very important, but you should not do in your board examinations like CBSE and CHSE. Suppose you are to find, a question is there, find dy by dx for the function x square y cube plus y fourth plus x fifth plus sine xy is equal to 0. First, if it is given, suppose it is given as 5, then what you have to do? You have to put that thing to left side. Means this implies your f is equal to x square y cube plus y 4 plus x fifth plus sine xy minus 5 is equal to 0. You have to take one side and putting that side as 0. Means you should put it as an equation. Suppose the name of this function is f. Now what is, you have to find what is fx. What is fx? With respect to x. When you will differentiate with respect to x, then y becomes constant. So y cube will keeping outside. Derivative of x square is what? 2x plus derivative of y fourth with respect to what? Suppose I am doing it here. Fx. You are keeping with respect to x means you are keeping y cube outside. Then differentiate this x square. It becomes 2x. Differentiation of y fourth is 0. And differentiation of x fifth, it is 5x fourth plus, here very important thing is del by del x of what? Sine xy. Means I am writing it here again, del by del x of sine xy. Okay. Previously we know what is the derivative of here. Look at here. X is there, y is there. Y will not come outside. You should think this is your box. Sine xy, sine box means its derivative is cos box. Means cos box. I am writing it again. It is cos box into what? Into del by del x of this box. Del by del x of this box is what? With respect to x, y is treated as what? Y is treated as constant. So it is cos xy into x because it will come to this side. So it is x cos xy. So plus x cos xy. What is with respect to y? If you will do with respect to y, then what will happen? Mind it, at that point x is constant, so x square will keep outside. The derivative of 3y cube is 3y square plus with respect to y, when you will differentiate, it becomes 4y cube. With respect to x, it is 0 plus the derivative of sine xy. Similarly, when del by del y of sine xy is what? It is y cos xy. It is y cos xy. And I think you can do it in your mind within 1 to 2 minutes. Now what is dy by dx? Dy by dx is equal to minus what? 2xy cube plus 5x4 plus x cos xy divided by 3x square y square plus 4y cube plus y cos xy. Okay, this is the answer. This is the short trick derivative. Short trick derivative for only for entrance examinations. You can do the problems of the implicit function which I have already given in my previous videos. You can do these problems in 1 line or 2 lines. These 2 methods can solve the entire derivatives in shortcut method. You can enjoy it. Using parametric form, implicit derivative, implicit functions, variable to the power variable, everything in derivatives. You can solve all the derivative chapters by these 2 methods. Okay.